In this video, let's solve the following linear programming problem. Here we have a company that makes two products. We're going to call them X and Y, and it makes these two products using two machines. We're going to call them machine A and machine B. Next, let's suppose that each unit of X requires 50 minutes of processing time on machine A and 30 minutes of processing time on machine B. Next, we know that each unit of Y requires 24 minutes of processing time on machine A and 33 minutes of processing time on machine B. Let's skip ahead for now to the available processing time on machine A and B respectively. For machine A, available processing time is about 40 hours. And just for the sake of keeping our units consistent, let's multiply that by 60 and write down that we have 2,400 minutes of processing time for machine A. For machine B, we have 35 hours available. Let's multiply that by 60 so that we have 2,100 minutes. Looking at the table that we have written down, this leads us to our first two constraints. We know that for machine A, every unit X that goes through requires 50 minutes, and we know that every unit of Y passing through is going to require 24 minutes. We want to make sure that we don't go over our allocated time of 2,400 minutes. Similarly, for machine B, we know that X is going to require 30 minutes, we know that Y is going to require 33 minutes, and we can't go over our allocated time of 2,100 minutes. Next, let's go ahead and take a look at our stock. Currently, we have 30 units of X in stock and 90 units of Y. Now, it's forecasted that we're actually going to need 75 units of X and 95 units of Y. This is going to lead us to our next two constraints. For unit X, if we're forecasting a need of 75, we probably should make sure that we make those 45 units that we're missing. Now, I could make extra, but I want to make sure that I at least hit the forecast of 75. And similarly for Y, the only difference here for Y is that we have 90 in stock, we need 95, so we better make sure we produce the missing 5 units that we have forecasted for unit Y. Now, the last thing we need here is that the company policy is to maximize the combined sum of the units X and Y in stock at the end of the week. This means we're trying to maximize P is equal to X plus Y, subject to the 4 constraints we have written down.